So that's how communications occurs over the internet. Some pre-agreed rules are used, and that's what these protocols mean. Okay. Next, what happens is uh, these comes the what's called the transport layer. Okay, this is what's there are different ways to transport something. So there is TCP, there's UDP, and those are just like using different courier services. Okay, so TCP is like they're like, I don't know, FedEx or something. They give you some very good guarantees that the package you're sending or the message you're sending is going to reach without any errors and things of that sort. Typically, when you're talking about e-commerce applications, you want very reliable connections. So TCP is typically what's used. UDP we will not worry about too much, but an example of UDP would be video. Okay, when you're watching a video, you don't care if 1 or 2 pixels this side or that side don't come through clearly, because generally you can see the whole picture and your eyes won't notice 3-4 pixels amiss. So UDP is for faster communication, and because it doesn't guarantee accuracy, it's allowed to drop some information sometimes. If you want to keep, so when you're watching a match, you don't care for being able to see every grass on the ground, every blade of grass on the ground, right? So, but the advantage of doing um, things like that is you don't have to do all the checks required for guaranteeing delivery. Okay, so but for TDS, generally UDP is not important. Another concept that will be useful later, which we will demonstrate what these mean. Okay, so ports is another thing. So ports is like when you're communicating with a computer, uh, there are many doors, as you can see over here, okay, that the computer may have. And you want the package to go to the right room. Okay, so port 80 typically is for HTTP requests, which is your web browsing. 443 is for secure web browsing. So like that, there will be different. 22 is for SSH. So that's what typically ports do. Okay, so you can think of them as doorways into your computer, different doorways, so that the right application is sitting behind this. So the right person is working in this port 22 office. The right person is sitting in the port 80 office. So port 80 office will, if you remember this HTTP, so the guy sitting behind port 80, he can handle HTTP requests. The guy sitting in office 22 or port 22, he will handle SSH requests. So that's how that works. So that's the transport layer. Then the next thing is, okay, you got a packet, you know how you've agreed on, so the chunking is done, you know how you're going to communicate with each other, what is the rule set you're going to use, and you know the courier you're going to use. Now the next thing is shipping the actual thing, right? So the courier itself doesn't own a shipping container and or an aircraft or anything. They aggregate things together and send it off on some service, right? Like the train or something. So this is where the internet layer comes. This is when you sometimes see people saying, no, what's the IP address? So that is telling what network it should go on to. Okay, so there will be an intelligent device called a router. It will look at the address. It's like your post office. It'll look at the address and know, okay, it says Chennai. So first thing is I'll go to the Chennai network. So they will send all your stuff to Chennai. Then when it reaches the Chennai office, there's another guy sitting there. Oh, it says Madipakam. Okay, so it needs to go to Madipakam. So then someone will take it to Madipakam. Maybe the local post office may have some more details. It's at this address, right? It's Chokonathan Street or something like that. And then it will eventually reach your house. Right? So that is what the IP layer does. Then there is something called the link layer. So once it reaches your computer, which is what that IP address shows, in your computer, there are many, usually there's only 1 or 2 devices, but there can be more than one device, right? So your computer should know which physical hardware should be communicating on that IP address, right? So when you connect to the Wi-Fi, it will get an IP address. So if you have another device in your computer, like a Ethernet port, that also will get its own IP address. So that is the link layer. These concepts may seem a little abstract for now, but you'll see why this is useful to know later. Now, what happens is when machines communicate with each other, they have first thing they do is they will look at the address on there, and like I said, they look up the address. So in computer speak, this is called DNS. Okay, that's where they look up their domain name server. Okay, and what that means is there's a phone directory. And remember, I showed you earlier, like, so if I, right. So earlier I told you, right, this name, okay, is actually mapped to a number, an IP number. So that's what the domain name server does. When you type in this word, and later I'll demonstrate to you on your system how you can sort of hack that so you can see what it really means. Yeah. So when you look up that domain name, then there's a directory sitting on the internet. So your internet service provider will have a directory. Companies like Google will have a directory. Cloudflare will have a directory. And so they send a request to these special uh, servers. Okay. And then they will look. It says github.com. Okay. What is the number associated with github.com? Once they find that number, then they're able to send it to that computer. So the next part of it opens the TCP connection that I was talking about. Then it secures it with a protocol called TLS if it's required. And then it sends the actual message using your HTTP application layer protocol. So this is the four-step stage that happens in normal network communications. So this is again just a quick sort of overview of what these different things are. It might be useful, say, for example, in the end term, when questions asked, you may get some basic questions on these sorts of things. But this is in a nutshell how computers communicate with each other. Any questions you have so far before I move on to the next bit? And we'll do some practical things.
So the terminologies which you have shared, those are related to networking and all, or are they the?
Sorry, can you repeat your
I'm
question?
I'm saying so the terminology which you shared, those were all were related to networking and uh, how the it works. Just now you shared no? The slide.
Yes, yes. Yeah, yeah,
Yeah.
yes.
Okay.
Yeah.
This one. Yes. So can you tell me what is NTP? Any?
So that is mostly more important for synchronizing time between various servers and networks. Okay. Usually, if the server or the router on your system is not synchronized correctly to the net, the time servers that are there, okay, then what happens is it affects the reliability of your communications on various networks. So NTP generally you will not have to worry about, but sometimes issues come about if your networks are not time synchronized. But typically your computer will handle that automatically because there is a service that is automatically available on your system that sit in sync with an NTP somewhere. So India will have its own
Mm,
NTP servers, and
okay.
India's own NTP servers will link up with the ones in the US. And so all around the world, everyone will be at the exact same microsecond precision, and that's required
Mhm.
for high speed communication networks.
Okay.
You don't have to worry too much about this. The other things will be useful at some point or the other, but NTP typically for us in TDS it's not that critical.
Okay.
Sir, can we get this all slides after this session?
Yeah, yeah, we'll put it together on GitHub and you can have it from there. Okay. And the next bit, probably what we should do now actually is, yeah, okay. So let's change the pace a little bit and we'll share from the Windows system that I'm running here. Just give me a second here. Join companion. That's the one. Okay, so if you've got your WSL working, the first thing is we'll need some packages, okay, before we can demonstrate some of these things. So let me increase the size here so it's a bit more clear. So one thing you should have done is already done the updates, okay. So have you guys all done the updates for your Ubuntu? I think it is updated. Oh.
So once we have updated it, we don't have to run the command multiple times, right?
Yeah, once you've done it, you don't have to.
Okay.
So what is the update command?
So updates. So I've explained it in the first session. What happens is there is a list sitting with Ubuntu's servers, which tells what packages are currently been updated, and your computer will have a list. And when those two disagree with each other, Ubuntu will send you the latest version numbers of the new things. That's what update does. Update informs your Linux system that the updates have been carried out. Sorry, the updates are available for your system.
Can
Upgrade.
you show the code once?
Yeah, sudo apt update. So it is up to date. Then the next thing is the first, I think, useful thing for most people to have is there is an application called UV. Okay, and I presume all of you are familiar with Python, right? There should be no one here that's not familiar with Python. So do you know what UV is? Have you used UV before? Any of you?
Sorry, what?
UV. I'll show it to you.
Yes, sir.
So it's a kind of package manager, but it is for specifically for Python. Okay, and it's very very useful when you want to run some tools and install some. Yeah, it's like pip. For some reason. You guys are able to see my screen, right?
Yes.
Yes, yes.
Yes, sir.
Sorry, just for some reason there's some issue. Okay, right. So this is what I was talking about. It's a package manager, project manager for UV. Sorry, for Python, and it's very very good. Okay, I super duper recommend using this, and you'll see in a minute. So if I go back to before I do that, the one way to install this package is if you go here, you can see in the introduction of it, there is a command here. It says Mac and Linux. Okay? Don't use Windows. Okay? Remember, we are not using PowerShell. We are using only Mac OS or Linux. So this is the command you have to use in WSL.
This command will work for WSL also. I mean Windows also.
No, it's not. Remember, WSL and Windows are two completely different things. They are not at all the same thing. There might as well be two separate physical machines. But I'll explain in a bit why it's not exactly the real truth. But for the purpose of your workflow, you have to treat them as individually separate machines. So you can imagine your WSL being a Linux computer that has got nothing to do with it. So you have to run only Linux commands, and you have to run it within this bash shell, as we call this, okay? The BASH shell.
Can you paste this command, sir, in the chat box?
So if you go to this site, right, this is the best way to get it, but I'll paste it in the chat as well. So this is the command, but normally what you want to do is, rather than copy it from here, always go to the site itself and get it from there. Just you can say copy to clipboard and paste it into your document. Let's run this. Okay, so UV is installed. Now what we'll do is we'll use another command now. Say UV init, and we'll give it a name. We'll call it like hello TDS. Okay. So something you might have noticed. So just after it finished installing, it says if you want to add it to path, you need to run some command here. So I'll explain this a little bit. Now, when we installed UV, it installed what's called a binary file, a binary executable file. So that's what applications usually have. So when you compare it to a text document normally you read, right? You don't execute it. So, or a text document generally does not have commands that need to be run. But UV is an application, right? So it is a file that's executed. So it's usually in the form of a binary file. Now, when we installed it, it's installed it to a particular location, but your Linux system doesn't know how to reach that application from the location where we are, which is, if you remember from the earlier session, we are currently sitting in /home/ in my case Carlton, but in your case TV or user. It doesn't know how to reach that command from here, so it doesn't know what UV is. But these other commands, pwd, etc., these are all inbuilt Linux commands, so it knows where to find the binary to run those. So we need to inform Linux, hey, there is a binary application called UV, and I want it accessible from anywhere in my Linux system, right? So that I can run it from here. So that's what this is saying. To add it to your path. So this idea of path is anywhere you're traveling in the bash system, if you want access to a particular command, you add it to what they call path. And so they've given this command here. Don't copy this bit. It's only here, source, $home, .local, etc. Right? So then what that does is it adds. So if you do this, then it adds UV to your path wherever you're working on the system. So now if we try it.
The first command curl installed UV, and this is directing the source, right?
Yeah. So this is telling where to find UV. Okay, it's adding it to your path.
Okay.
So if I do UV init, so it worked. So this word UV is the application that we are trying to run, and the application itself has some commands that you can run, right? So so what I did is I said UV -- help, and then it gives a little bit of help. So what all things UV can do. There is various commands it has. So it has UV auth, UV run, and we use this one, UV init.
And hello TDS is ours name,
Yeah.
no?
Yeah. That's why I chose something simple.
Okay.
So as you can see how to use this command, there is an application name called UV. It has some options and some commands, and then it gives you, when you do -- help, and you can do this with almost any command in the Linux system, it will give you a little sort of help on how to use it. So what we did is we said UV init, which is this. So it's to create a new project. I said UV init, and one of the parameters that I give for that is the name of the project.
Right.
And we did it from our home directory. So look what this does for us. So if I look here, you can see there's a folder called hello TDS. But inside that hello TDS, there are 3 files. There's a readme file, there's a main.py file, there's a PyProject toml file. So don't worry about what those all are. But we all know what a Python file is, right? So if I do cat, which is another Linux command, you can see the contents of this file, right? So it's a basic Python application is what that is.
Automatically created these three files.
Yeah, just by saying UV in it created the directory and it created these files.
Okay.
And
Every project will have this, right?
yeah, and if I do one more thing, right? If I do ls -a, notice there are some more extra files in here. So initially it showed only the visible files, but there are some invisible files. So .git ignore, .python version, these are invisible files initially. And it has also created these files. Now, I won't go into why these are important right now, but these are fairly standard things you will require every time throughout TDS. So instead of manually creating all these things all the time, if you just do UV in it, it will prepare this project for you straight away. Now the next thing.
UV is a text editor or what? Or it's a
No, it's not a text editor. It's a package manager and a
Package.
package and a project manager for Python specifically.
okay.
Yeah, and a lot of applications you will develop it in Python, but that's not necessary. If you're comfortable with Java or JavaScript, you can do them in those languages as well. But I assume that most of you will have Python because you're on this degree program. So that's why we are focusing on using package managers that are related, that you will be familiar with, rather than using something that you're not familiar with. And this is an excellent package manager. Now, next thing we can do is we can create a small. So to recap. I'll just do a small recap. Remember, we wanted to install something, so we went to the site and got it through curl. Another way to get applications, right, is through a package manager like apt. So apt is a package manager for Ubuntu systems, right? So you can always get packages for your Ubuntu using apt. But by the same token, you can also use Homebrew as well. Okay, and this is what I recommend. Not recommend. It is necessary for people using Mac OS to use Homebrew, because Mac OS doesn't come with the package manager, but instead it will use Homebrew as the package manager. And the good thing about Homebrew is you can also use it in Linux. So you don't have to use only apt. You can use Homebrew as well. And you just copy this command from here. There's a copy command here. And you can install Homebrew also on your system. So I'm going to do that now. So it will install this.
It's okay if we are using apt. Or
it's okay if you're using apt, but there are some advantages to using Homebrew, which may not be apparent immediately, and it won't break your system anyway. You can always still, even after installing Homebrew, you can continue to use apt for all your package requirements.
Okay.
But Homebrew does some things in a nice way. So, and for Mac OS, you absolutely need Homebrew. That's why I'm just showing it here real quick.
Okay.
And Homebrew installation, once it's done, there are a few extra commands you need to run. So, of course, again, remember putting things on path. So if you want Homebrew to be available on path, then you have to run in the same way. You have to run these commands. So put that on here. So now Homebrew will be available on path. So if I type brew to update, so now it can locate the application, right? So, and then the next thing is, it says Homebrew sometimes requires some additional things.
Sir, are you presenting? Because it's his host.
Is my screen not visible?
Visible.
Yes, it is.
Visible.
So you might need to probably just log in and log back in. A couple of other things with Homebrew. You want to install this application called build-essential. Okay? This is not just for Homebrew. It's actually useful for a lot of things in WSL anyway. So even if you're even if you're not using Homebrew, I would highly recommend you to install this package. So now notice I'm using apt, okay, to install this. So build essential. Okay, so it will ask you some questions. You say yes. Now this is using apt, the Linux owns package manager. Okay. So once it does all that, so there are a lot of applications, and this will be essential later, okay, during the TDS course. So that's why I'm showing it to you now. This build essential is very valuable. So build essential has a multiple packages, okay, and they're all useful for building more applications as you download them. So that's why we install those. Then one more thing they say in Brew, they recommend installing the C compiler. Okay, so that's what this GCC means. So we can do that as well.
Brew is for Mac.
Yes, Brew is for Mac, but you can also use it in Linux. It doesn't harm you in any way. So now I can just do Brew install GCC.
But in my Windows system, okay, inside the Linux thing, I can do the installation.
Yeah. All these instructions from now on have nothing to do with Windows. So we are not going to use PowerShell, and we will not support directly people using PowerShell. So all our course is geared towards you using a Linux environment. Okay, I can hear a
Aman,
lot of
please mute.
disturbance. Thanks. So yeah, so it's installing the GCC. Okay, it's taking a little bit of time. All right. So while that is,
what is meant about GCC?
it's a C compiler. So the reason for that is, yeah. So what happens is certain applications. So this is the other difference between Linux and Windows operating systems. So when you're downloading an application, it already has the compiled binary and executables, everything, the libraries, everything are wrapped up in a single package. And so the installation sizes are massive, okay, for applications that you're downloading for Windows. So if you've got some data internet issues, or if you don't have fast internet, etc., it takes a long time to send things over the internet, especially when the packages are big, and errors can come. Then you have to re-download all these sorts of things. Whereas in a Linux system, that's not how it works. What they do is they send just the bare necessary things that are required. The source code and all those sort of things are sent, and it tells what that application depends on. And then in your computer, once it gets all the requirements, it then just draws all those bits and pieces together and builds the application inside your computer rather than downloading the pre-built application. So the advantage of that is Linux applications or Mac OS applications, they tend to be very small in size because they do the building work inside your computer rather than downloading already the pre-built file. You see what I mean?
Yeah. Thank you.
So that's the big advantage. So this GCC is a compiler, and what it does is it looks at C code. So if you've created an application in C, all you have to do is send a few 2-3 KB file that explains what your application is, or Python file, or whatever it is. And GCC actually builds your application inside your computer by creating the executable code and all that sort of stuff. So, okay. So while we're waiting for that, the thing I wanted to show you, okay, so install GCC, so that's fine. Okay. Now what we'll do next?
So we can install Homebrew in our
Linux.
Linux, right?
Yeah, absolutely. And I recommend it as well. It's a very good application manager, package manager. Okay, so that's installed. Now we have UV. Okay, that's great. Now let's create a. So I'll explain why we are doing this.
So can we do apt install GCC?
Yes, you can do it, manage it via apt, or you can do it via Brew. It doesn't matter.
Okay.
Yeah. Okay. So next thing is, a second here while I pull up. Just give me a second, okay? I'll just take a sip of water.
It will be globally installed, no? If we are installing the folder hello.tds.
So this is for Mac, no?
No, for all.
Yeah.
GCC is for both. Homebrew for the both, sir, what telling. But in the Mac, Homebrew is essential. Without Homebrew, you will not be able to install this.
No, Homebrew is the package manager, and
For
GCC is
Homebrew for Mac.
we are installing in the main
Yeah.
system,
Yeah.
not in the virtual environment.
And this GCC is in virtual environment.
Right, okay. Right, so just to clarify, yeah. So Homebrew is a package manager. You install it in your Linux system. Mac OS people absolutely require it because they don't have a package manager. So Homebrew is the default package manager for Apple. And in a Linux system, you don't need Homebrew, but it's useful to have. Whereas GCC is just an application that is useful for building other applications. And it might not be evident right now why you need it. But remember, we are setting up your environment for TDS in the future. So these things are good to get at the moment.
Sir, one doubt. How to check the if brew is working fine? I mean the version and update.
So usually what happens is you can just type in here, right? When you type brew, it will, if it shows something, that means brew is working. Right? And if you want to update it, you just say brew update, and it will show that the application is working.
So this we have installed GCC, whether it is globally installed or installed in the Hello TDS project only.
No. GCC is installed globally. These are applications there.
Okay.
Yeah. Because it's a binary executable. Anything that your application manager installs, they are generally installed as a binary, as a global, or rather as a binary executable stored in a binary somewhere. And accessing that depends on whether you want to put it on path or not. So brew we put on path, that's why brew is working. UV we put on path, that's why UV is working. Some Linux commands are already inbuilt on path, so you don't have to worry about those. But they also are little executable applications. So when I type things like PWD or LS, these are actually little applications that have a specific
task. We did not give any command for that, no? Brew on path.
We didn't, because Linux by default installs these PWD, LS, all these things. They automatically add it to your path.
Okay.
So that's why you don't have to do that. These are like considered essential commands.
Otherwise, we have to go to the Windows and environment variables. We have to change the path. Is it?
Not Windows. Remember, we are working in Linux. So everything, all the commands that we are running, the path variables, everything, we are doing it on Linux system. It is not happening in your Windows environment. Your Windows environment is completely isolated from the Linux system.
So we have to change the path for some packages.
Yeah. So that would again be inside your Linux system, not on Windows.
Okay.
Yeah. Right. So the next thing what we'll do is so I wanted to show you how computers communicate, right? So first thing we can do probably yeah. So there's this command here called IP-addr show. Okay. And what this does is, so if you remember the chart I showed you earlier, right, of how computers communicate. So this shows us what physical or virtual devices are there available to your Linux system. Okay, so you can see here there is LO, which is the loopback device, and there is H0, which is the networking card device. Okay, actually these are both networks. Sorry.
It's the Ethernet, right? ETH0.
Yeah, so you can think of it as Ethernet. In reality, it is a virtual network card. It's not a real network card. But if you think of them as devices, right? So there are two devices available in your Linux. One is the loopback and one is this H0. These network devices have been given a specific address. Okay, so you remember I told you about IP addresses, right? So this one has been given 172.19.45.80. And don't worry about this /20 for now. I'll explain them a little bit later in the session. What's the time right now? 2:50. Okay. So this is the address given to your card. Okay. So now, if you want to be able to communicate with this, right? So the question is, how do you do it? So there are a couple of different ways. Okay. So one is you can just ping and say, I think it is C for Linux systems. So say ping C4 and we put this 172.19.45.80. See what happens. Right. So you see it's responding. Right. So it's saying send 64 bytes to this address. And it took like 0.024 milliseconds to return a result. Okay. So it's working. Now, if I change this to 81 or something, nothing is coming, right? Because there is no machine with that IP address. So now we got complete loss of packets. 4 errors, 100% packet loss. It's not reachable. Same way we can look at the other one, which is 127. Oops. So the reason I put C4 is send 4 packets. So that's the whole idea. So you can see that also is working. 127. So what's the difference between this number, this big ugly looking number, and 127.0.0.0? So every computer has an address that is publicly visible, which is what that 172.19.45.80 is. And then there is a reserved address. Okay, so this will be the same for every computer, every networking device on the planet. So the reason is for this is someone long time ago, about 50 years ago, decided that this is how we will, this is the rule we will follow. So every networking device will have a 127.0. And what that means is, if there are some applications inside your computer, right? So imagine you have an application that, I don't know, keeps, has a thought for the day or something, right? And if you contact that application, it will tell you the new thought for the day, or there is some other application that keeps your to-do list or something. So all these applications, if they want to not talk to the outside world, right? They only just want to work within your computer. So what you can do is you can have them broadcast their communications on the local machine, right? So this 127.0.1 means contact this local machine. That's what it means. So that is what you got to remember. But when the outside world, you want communications with the outside world, you got an outside facing address. And that's what this denotes. Okay? It's an address that is assigned to your machine. But this is your internal address. So applications can communicate with each other across this IP address. Okay? So that's the key difference. This is important to remember. This can change from depending from machine to machine, etc. And we'll talk about those things. All right. So enough itself, this doesn't seem that useful. So we'll just do some small exercise. So I'll use the cat command again, right? And I'll create a new application called hello.py. And so don't worry if you don't understand this terminology. Ritik will cover all these things. So these are what I call piping, right? This application cat.
So do we also have to follow you, or?
No, not at the moment. At the moment, you just watch what I'm doing. But you can try also, no problem, if you want to try. But what's happening is I'm telling this application, anything that is input, I want it to go into this file. And when the file uses the word, or whether standard input uses the word fin, the file editing is done. Okay? But don't worry if you didn't understand all that. It will be covered a lot more detail later. But this is just so that I can quickly type up a small application. Okay? So you all are familiar with Python. So we'll write a very tiny Python application. So we'll do.
So can you zoom the screen?
All right. Yeah. So,
Yeah, better.
then
What is the fin is doing? Fin command, fin?
I'll explain in just a second.
Okay.
Okay. Now, so I've used this application called cat, which is inbuilt in Linux. I've told anything I'm going to send via input, right? So this is all the input I'm giving it. I'm going to put it in a file called hello.py. And this symbol tells it when it's reading from this stream. If you encounter this word fin, that means I've finished typing the file, because otherwise it won't know when I finished, right? So notice I did that. And now if we actually look at the contents of the file, that's the contents of the file.
Got it.
Yeah. So that was very quick and easy, right?
So fin is just trying to tell you that you have to end the code has ended and you can stop now.
Correct. And this can be any keyword you choose. Okay. It can be EOF or
End of
whatever.
file.
Yeah. It's basically telling if you encounter this, whatever is in this, then that means you've reached the end. So I just put fin for finish, right? But it doesn't have to be fin. It can be anything you want. But
And
that
so
is,
before fin the symbol, what is that called?
Yeah,
This-
less
yeah,
than,
so-
less than. Word.
yeah, so this is a redirection
Symbol.
and these things will be covered in more detail later. I don't want to spend too much time on the nitty-gritty.
Okay, fine. Okay, fine.
Because I want to demonstrate something,
Okay.
so that's why we'll do this. Okay, now
So basically, we'll be having the hands-on for these, right?
so now we have written a Python file. We have UV, the package manager. Now we want to run this application, but we didn't create a virtual environment. We didn't import this library called FastAPI. We don't have Uvicorn to run a web server. None of these things we have, right? So what I do is I just say UV add FastAPI, and we can get Uvicorn also, and done. Okay, so it has done exactly what you would normally do: pip install, create the virtual environment, all these things it has done automatically for you, right? You don't have to worry about it at all. Now let's have a look at how this works. Okay, so now I want to launch the web server. I say Uvicorn, and we want to run the Hello application. So inside Hello, there is that app, right? We saw here, little app. So run the app.
Every time we have to call through UV, right?
Yeah. We will call through UV, yes.
And the virtual environment.v and v we have created inside the project only hello TDS.
Yes, it does it through the UV because we are working in the Hello TDS folder. It has automatically done that for us.
This virtual environment particularly for this hello TDS, not for the global.
Yes.
Okay, fine.
So for calling a function, I mean the application, we have to be in the same level.
Yes, correct. Yeah. Because you're running this project, right?
Yes.
So that's what. So this is where the communication part now becomes important. So that's why I created this little application. Okay, so all I'm telling is, okay, UV, I want you to run this web server called Uvicorn, and Uvicorn has its own rules. So first thing is I'm telling there's a Python file called hello. Inside that Python file, there is an application called app. This just tells it if there are any changes to the file, just reload the server. So don't worry about that. But then this is the important bit. I'm telling Uvicorn where to run the server, as in where to make it available. So I want it available on 127.0.1 and this port 8000. Okay. So if I run this, did I spell it wrong? No, that's correct. Actually, I might not need to say UV, probably just UV. I thought it was already installed. UV add Uvicorn. Yes. Oh, sorry. Okay. Sorry. Yeah, I just realized. I think it's UV run Uvicorn. Yes. Yeah. Okay. So it's UV run. Okay. I forgot to add that run part before that. Okay. So now this web server is running. Okay. And if we click on this,
This is anonymous 12701. We can assign at our end.
yeah. So remember what I told you earlier, right? If we only want communications to be inside your computer, then
Okay.
this server will be available only on this particular number, 127.0.1. Now, if I open the browser, it's probably not that clear, but notice I put the address 127.0.1 8000, and you can see it has responded. Right? This response has come from our server that we just started running inside our Linux system. Okay, you can see that, right? If I refresh this, right? So you can see the logs here. If I refresh this, notice it's got a request, right? And it's coming on 127.0.1, but it's coming from a different port, the request, but we are accessing the 8000 port of this Uvicorn server. Okay, is that clear? What's happening?
Yeah, and we are getting this message hello TDS from our hello TDS file folder or server.
Watch it. So over here, notice we created this application, right?
Okay, the same thing.
So what this app? So now I'll explain this application.
Okay, got it.
What it's doing is it's looking for
root. Okay.
Yeah, so it's looking for this. Okay, this slash. Now,
It's
typically
route.
browsers, if they don't see the slash, it just assumes the slash anyway. Okay? And it looking for this slash. If it finds this slash, then it will run this function. So there's this home function. This home function just returns. Now this is what's called a JSON. Okay?
Got it.
Return this JSON body, and that's why you're able to. That's why you're able to see this response that has come. Okay. So that's how this works. So okay, great. Now we know that this is able to communicate with this. But there is one problem, right? You can't access this anywhere outside your computer. Great, you have a service running, but you cannot access it outside. So how do you fix that problem? That's another question to solve.
And 1404 not found. Why it is telling?
Okay, that's because we used a browser, and typically browsers want an icon for a web page. So it has requested not only the 8000, whatever is on 8000, but it's also saying, hey, do you have an icon that I can use for the web page? So whenever you look at web pages, if I go to,
Okay, got it. Okay. It is
see,
not
there
there.
is,
In
you
our
see this,
app, you have not defined. Okay,
correct,
got it.
correct. So
Got
here
it.
there is a little icon, here there's a little icon.
Mhm.
So the browser is asking, hey, do you have an icon for me? And the server responds, nope, I don't have an icon because we haven't configured an icon.
Optional requirement. Okay.
Okay. All right. So, so that's fine. Now the next thing is, how do we access this from outside is the more significant question, right? I mean, we want to be able to, for it to be useful, we want it to be able to access it outside your browser, like on the network. And if I just pull this up here, just give me a second.
Hello.
Yeah.
So can you explain all these things after running the Uvicorn? After running the app, so many things are showing. So can you explain each line or something?
Oh, okay. I won't explain each line, but I'll give you the overview of what's been happening. Okay.
Sir, can you explain the last two line finished server process 5107?
So these are just logs, okay? Because what has happened is I pressed Control C and stopped the server. Okay. When I did this command, the server was running, right? Yeah.
Yes, sir.
Okay.
Yes.
And when the server is running, there is a process. Okay. So it's telling what processes have been loaded. Usually there'll be multiple processes running.
This is
All I did
5121
was
and 5123 the PID, process ID.
possibly, but these are
Okay.
various processes that are running.
Okay.
But I wanted to stop it, so I said Control C and stopped it. So then when it stopped, it said, okay, finished this process, stopped this process. So that's just logs from the system.
Okay, sir. Okay.
This stage probably will just stop this screen share for a second, and we'll go back to our slides to show you what happens next.
Yes, sir.
Okay. Now, sorry, this session took a little bit longer than I was expecting. So far, you guys are with me, right? You've understood what I've shared, right?
Yes,
Yes,
sir.
sir.
At least 80-90%.
Okay. You can rewatch and you will understand it better.
Yeah. We will do it at our own, our
Sure.
system. Then.
Okay. Now to share this. Yes. To share. Okay. So now, although this picture is not that helpful, typically what's happening is your WSL is basically a virtual machine sitting inside your computer. I know it shows it as separate here, but that's because it's showing that it's being isolated from the rest of your Windows system. It's not a pure isolation in reality, but this picture at least helps you from a developer perspective. So this is kind of the mental model of it. Here's your virtual machine. It's running Linux. It's got some resources allocated to it, but it's actually sitting inside your physical hardware, okay, which is where your operating system, Windows OS is running and all that sort of thing. Oops. So then, you remember earlier I was telling you about that internet IP address, right? So inside your virtual machine or your Linux machine, there is a virtual Ethernet card you can think of, right? And it's given some internal address. And in order to communicate with it from the outside world, you would need to know what that address is. For applications running inside your system, it doesn't matter. But once you want to connect to the outside world, or rather you want, so if I go back to this previous slide. So what I want you to think of, the way of showing this. So typically what will happen is some communication will occur with your physical computer, right? And from here, there may be an address of, remember, this is still inside your network. Terrible writing, sorry. This way, 2.168.1. Okay. And so, yeah, so typically what will happen is you will, this won't be the address, okay? It'll be like 100 or something like that. So it will communicate with your computer, but the outside world has no idea of what's happening inside here, inside your computer. So the goal is to get this information that's coming through this pipe, change the color here, and it then communicates with your virtual machine. Okay, and inside here you will have that 172 dot etc address inside. So your Windows can see that, the outside world cannot see it. So we're going to try and see if we can get this interface to work. Okay, and that's what the next step is, which is basically getting, clear the screen here. Yeah, so it's basically getting communications from here to here. So that's what we're going to try and do. Yeah, this is just some terminology which is which says that it's done using NAT by default, but don't worry what that means. This is not necessary. Yeah, okay. Right. So this is what I was talking to you earlier, right? If it's on 127.0.1, your VM can hear it, right? The communications that are going on. Now I know here it says Windows host cannot hear it. That got changed recently. Before, when you did 127.0.1, Windows typically would not be able to communicate with your Linux box, okay? But in a recent update, what they did is they also connected the 127 with the Windows 127.0.1. So that's why we were able to reach it from our browser, even though it is meant to be only inside the Linux VM. Okay? So the isolation is not perfect, in other words. Okay? But definitely the internet cannot see it, or even your local area network cannot see it. So you may think, why is all this important? A lot of failures we see in TDS comes from not understanding these networking concepts. You know, people will say it's running on my machine. I've tested it on my machine. The service is running on my machine. My machine is able to communicate with the outside world. But guess what? We are not able to communicate with your machine on the inside. So whenever we run some evaluations on your projects, if we cannot communicate from outside, your project is as good as getting 0, because we cannot evaluate it. And you may say, oh, that's unfair. But here's the reality, right? Any project you build, you have to know how to make it visible to the outside world to deploy it. Deployment is a very, very important concept to understand. And we find term after term, this is where most of the problems lie. Students don't understand the concept, and so they find it difficult to debug the issue. And you can use ChatGPT and all, but that has some limits, because it partly depends on how your network is configured, etc. And so when it comes to working out those problems logically, ChatGPT may not understand the context. But if you understand the context, you are able to give ChatGPT better prompts, right? You're better able to explain the problem, and then it's better able to fix it. So this goes back to the analogy I told you earlier about the car, right? If you understand a little bit of how the car works, you will get better outcomes. So that's the whole idea. So one way to fix the problem of not being able to hear on 127.0.0.1 was to use this. This is another rule that was set up decades ago. There's another reserved address apart from 127.0.0. So remember, 127.0.1 is for your internal machine, and O.O.O means broadcast to every device that is on that network. So since your Linux machine is sitting on your Windows machine, they are part of the same network. And because they are part of the same network, when you broadcast on 0.0.0, all the applications inside your Linux machine can hear the server, and all the applications sitting on your Windows machine also can hear your server. This is slightly less of a problem than before because Windows now allows 127.0.1. But rather than helping, that has actually confused things a bit. And I'll explain why. Now, you may decide, okay, I'm going to host the service on 127.0.0.1. Then you will do some routing to your computer and say, okay, now my service is ready. But guess what? It cannot still hear it because this rule is universally followed by most networks. Okay? They follow this rule that 127 is only for the inside machine. So this is why you need to absolutely, when you're running a service for public consumption, then you need to put it on a broadcast where everyone can hear it. So that is the reason for this O.O.O.
127 is for WSL, no? Virtual machine.
It's not just for virtual machines. So it's for that physical machine or that virtual machine. So even your Windows will have its own 127.0.0.1. There will be, it will have its own card inside. Okay, there will be clear this.
Address.
Yeah, hang on, I'm just trying to. I don't know what that happened. Just 1 second. That's fine. Okay. Yeah. Just clear all this. Yeah. So your Windows also will have a 127.0.1. That's my point. Even your machine, my machine, the Linux virtual machine, all of them will have a 127.0.1 that only they, in theory, if they follow the rules, only they should be able to listen to. Nobody else should be able to listen to. So only the applications running inside the Linux machine should be able to listen to it. Only the applications running inside the Windows machine should be able to listen to it. Can we describe like we open and provide access to the rooms? Yeah, I mean that's a good way of describing it. Yeah, only the people who are working in that office, right? So the Linux office, only those people can hear 127.0. So if someone says, "Hey, I'm broadcasting on this," it's only for people inside the office. But 0.0.0 connects both. I shouldn't say the word connect. It means broadcast on in the corridor, and the corridor has both machines connected to it. Both offices are connected to the same building, right? So this is like broadcasting into the corridor. Ports we'll talk about a bit later, but for now, it's enough to understand this idea of using 000 versus 127.0.1. Port we'll talk about a bit later. Right. So going back to
So, sir, if we broadcast it to the 0000, then both the machines will be able to see.
correct.
Okay.
That's the whole idea behind broadcasting. I guess now is a good time as any to know.
Sir, in case of Mac laptop, then we don't need to do this kind of port forwarding, yeah? Like IP address forwarding. No need.
Yeah, I mean, because you will be running directly on your Mac machine. That's why you don't have these issues. Same with if you're running a direct Linux machine without WSL, you don't have these complications. Yeah, that is true.
Okay, thanks.
But since most people are going to be using Windows and WSL, that's why we have to go through this a little bit.
Yeah, yes.
But it's also useful to know for Mac people and Linux people, okay? Because you still have to understand how networks work, right? So in other words, even if you on your Mac system broadcasted on 127.0.1, it is still inaccessible to the network. Do you see what I mean? Yeah. Okay. Thanks for the thumbs up. Okay. Right. So now, was I'd earlier set up net.sh function. So sh. One second. Just give me a second here. Meanwhile, if you guys have any question, I don't know if there's the other TAs are on the call or see.
Sir, mostly our say example in our software requirement, it was mentioning we need to install VS Code, those things. So
Yeah.
here we are using the cat. So are we extensively using the cat, or it will be we can use the VS Code so that we can prepare the entire end-to-end application?
Yeah.
And also,
You
is
can,
there any IDE we can also install, like IntelliJ, we can also install like that?
yeah. So the reason I showed you through the command line is because all your applications will anyway talk through the command line, right? So that's part of the reason why I showed you through the command line. But you're right. We can use VS Code to directly edit files and create applications. But it was worthwhile knowing how to do things through the command line, because when you write scripts, right? Typically, scripts will run command line commands, right? It will
That's right.
run commands through the command line, like when you're
Yeah.
piping things from one application to another. So that's why I showed you that. So at least you have some exposure to the idea.
Yes, sir, you are correct.
I haven't used Windows to do development for quite some time. So probably Jivraj can let me know what I'm doing wrong here.
Titan, I cannot see your screen.
Oh, you can't see the screen. Oh, sorry. I thought everybody could see the screen. Is it visible now?
Yes, it is.
Yeah, visible now.
Okay, sorry. Connect to WSL. It's not working. I haven't used Windows for a while.
Is there any difference we use the terminal Ubuntu terminal in the VS Code and the Ubuntu terminal in the WSL?
Typically, I would say it depends on whether the correct terminal has been opened or not, and that's largely dependent on whether you're connected to WSL or not.
No. If you in the VS Code we open Ubuntu terminal, particularly.
Yeah, then it's okay. Yeah.
Then it is the same, na?
It should be.
We are doing.
But right now, if I open the terminal, I think this is not opening.
The plus sign we will see here. In the bottom right side plus sign we will open, Ubuntu will open. Bottom, no, just a plus
This
sign.
one
Yeah,
here.
here.
Yeah, but
Arrow. Drop down. Ubuntu will be there perhaps.
I'm not seeing it. That's the
New
problem.
terminal. Here it is. I have seen. In my system, it is there.
Okay, let me do one thing. Let me just uninstall this. I'm not sure why it's not working.
For this, we have to, I think, install in VS Code.
This probably will fix the problem. Okay. Meanwhile, I think maybe Jivaraj can show you because he's got WSL. I think you have WSL, right, Jivaraj?
No. I'm using a different laptop which doesn't
Oh,
have
you're
this.
using Linux, is it?
Not Linux. It have Windows, but I haven't installed WSL. And I can join from a different laptop, but it have Arch Linux.
Sure.
Carlton sir, sorry, I'm joining a little late. I just wanted to know, will the recordings will be available for these sessions?
Yes, they will be.
Okay, thank you so much.
Sorry, it's taking a little bit of time because I thought it will connect directly, but for some reason it didn't connect. You might need to just reinstall this VS Code. Maybe I have to reinstall this extension. Okay.
Extension is required for that.
Yeah, if you want to run.
Yeah, for
run it
Ubuntu.
within-
For Ubuntu, extension will be shown in the drop down.
Sir, actually, in the down bottom corner of left corner, there is an option download for WSL. Yeah, so you need to download it there. So basically, what it does is it actually downloads a code server in Ubuntu or WSL, and then you can use directly from there. So like there, if you write code, and then the directory you want to open, it will automatically open in your local machines VS Code. So essentially, you need to
should I
click there
use?
and
Should I
download it.
use connect to which?
Yeah. You need to do connect to WSL. This is only one time. Okay, so once you connect it, it actually downloads. Okay, so it's not able to find a distro in your system actually.
Yeah, that's what I've never encountered this error before.
It's not able to find it actually.
And I'm not even able to uninstall this extension also. I think there's a corruption in the extension.
Carlton sir, could you go to one link? The VS Code normal uninstall does not uninstall completely VS Code. There is some instruction.
Okay.
Yeah, you need to delete some more files to completely uninstall. One ChatGPT link I have tested. Maybe you can try that.
Go and delete all the folders basically.
Okay. What I'll do is, rather than take up time in the session, maybe Hrithik can. Do you have WSL, Hrithik, on your system?
No, I am currently in Ubuntu system.
Okay. Okay.
Maybe we could take the topic like
Sure.
bashrc or other.
Yeah.
You can take it pending. We will do it later.
Yeah, that will be good because meanwhile I'll get this fixed offline and then start back on the session. So currently our session was basically to cover networking, right? What I wanted to show you. Okay, I'll do one thing. Instead of showing about VS Code, I actually don't know why we went into VS Code, but what's this? Okay. Yeah. So if you guys, I'll stop presenting now for a second, and if the TAs can just take over the session for a couple of minutes, get the other things ready, and then we can continue.
Yeah. Means should we start some topic or just take doubt for now?
You can if people have doubts, you can take doubts, but if you can go to the next topic, that will be good. So,
should I cover bashrc?
Yeah, could do. Yeah. Yeah, that will be good actually, because they will understand how commands and things work. Right?
Okay, I'm sharing my screen. Yes, sir.
Sir, when you shared this chat link, chat GPT link, is there any version of this? Because it's unable to load conversation, it's showing in my chat GPT. Is it? some version, advanced version, or everyone is
click on this.
able to open this one?
No, it's not visible for me also.
Yeah, some it's a
Maybe
paid
maybe
version
I
or
have
something like
copied
that.
this link. No. Maybe I have copied this link. I am resharing it.
Okay.
Okay, my screen is well visible. My VS Code or
Yeah.
anti-gravity is visible.
Yeah. Okay. Now
Yes,
it is opening.
So let us. So I have. I have prepared this note in this 10 minutes ago. So we will read every line and we will understand. Okay, what are the things? The first thing is two things we need to understand. One is the path variable and one is the bashrc file. Okay. So what is variable? If you open a terminal, I am in Ubuntu system, so the terminal is my Ubuntu. I hope my terminal is visible. So this is a terminal.
So your Gmit screen is visible.
A screen is visible, but not terminal.
Not the.
Okay.
Sir, I think your screen is freeze.
Please, yes.
Yeah, let me reshare the screen. Visible?
Yeah, visible, sir.
Yes.
Yeah, my terminal is visible now.
Yeah, sir.
Yeah, visible.
Yeah, so this is terminal and this is a terminal, but now I am using a anti-gravity and the terminal. Okay, so why not to use both at the same time? So there is also terminal. So this terminal and that terminal are
What is anti-gravity? Is this?
Just VS Code. Okay.
Okay.
So there are two things. The first thing is the path variable and second thing is the file. So what is variable? So in Python, you write something like a is equal to 10. So that is a variable, right? In bash also, this is bash shell. And here also, this is like variable. So in Python, you write something like print. And if you type a, it will print it. But it is saying, hey, I am a bash shell. I hope it is, I have written in the terminal and it is visible to you, right?
Yeah, it's visible.
Yes.
Yeah, so it is saying that, hey, there is syntax error. So it is not able to pass this because this is a Python, it can be passed by Python interpreter. So in bash shell, there is command for print, that is echo. So echo is a command for print. And if I want to print a, so this is treated as a string. I want that treat as a variable, so I need to provide a dollar here. So this is a variable part. Okay. So variables are defined like a is equal to 10 and variables are executed like echo $a. Okay. So this is the rule for variable in bash shell. So bash shell, you can think like it is also a programming language, but visually we say that it is a scripting language. Okay. So anyway, it is a language which is interpreted again. So high level language, you can think like that. So this is a variable and this is the printing that part. So this is variable a is equal to, if I type hi and if I type echo $a, that will be printed as hi. Just like that, there is one specific variable that is path. Okay. So if I type like path, okay, if I type something like path, it will print path, but there is its value. If I want to print its value is this. Okay. So this is its value. This is a string and it is value. Okay. Okay. Let me see what are the files in my current folder. So these are the different files. And if I type ls, you can see these are the files that are there, right? Visual?
Yeah, ls which inside path.
Yeah, I typed ls and this these are the files that are there. It is listed
in the
right?
folder of a live session. In the folder of live session.
Yeah, these are the files, correct?
Yeah.
Yeah, let us change the value of path. And I am changing it to anything I can change. I can change to current directory only. Okay, I have changed the value of path. Let me execute this ls command again. Can you see what?
Your screen is stuck.
Your screen is getting frozen.
You typed something, no? Frozen perhaps.
Okay.
I think you should use the terminal itself.
No, just wait some moment.
VS Code, I think it will be better. Maybe anti-gravity is hanging.
Moment. Okay. Yeah. Now my network should be fine. Okay. What I did, I opened this terminal. Okay. Terminal visible?
No, it's not.
It's not visible.
Refresh it.
It's visible for other people.
No, it's stuck. A screen is visible, it is stuck.
Yeah, now my terminal should be visible. And I'm moving terminal.
No.
Yes, now it is.
Now it is.
Yeah. So what I said, we can define variables like echo $a. There is nothing in the variable, so nothing printing. Let us define variable hi, and we can
Are you
print
typing?
Again stack.
Again stuck. Okay.
Terminal is visible, but nothing is typed here.
Is it now visible? I am typing something.
Yeah,
I typed something.
Correct. Yeah, correct.
Yes, sir. Now visible.
Working.
Yeah. So I just said that variable are there, and if I type ls, I can see there are some files, right? And I am saying that there is some variable that comes with operating system, like this path. Okay. And I want to change this path variable value, so I just change it to dot or something like that. So now if I echo the path, the value it's changed, correct? I'm saying I want to list all the directories. So what the command? This ls command, correct?
Yeah, ls.
But can you see the ls is not working? Okay. So
because
definitely there is something to link with this ls command and this path variable. Is this agenda clear?
Yeah.
And that linkage is also, it is saying now command ls is available in following places: bin ls, user bin ls. And here it is saying the command could not locate because bin user bin is not included in path environment variable. So there are two information it is giving. It is saying that, hey, ls is here, means somehow it is able to find where is ls. Then second, it is saying that this is the path, but it is not able to locate the path. And what is the reason? Because that is not included in the path environment variable. So there are two things. One is the variable and one is environment variable, and one is the path environment variable. Okay. Are you getting it?
Yeah.
So this path value I change, and you can see this bin or user bin is here present. This bin is here present in the path variable, and I change this path variable. But okay, I change the path variable, but if I reopen a new terminal, and if I type this echo path again, the path value comes back again. Okay, it means this changing value is temporary. So there are something to note for you. If you change the value normally in terminal, that is temporary. That is for only current cell. Okay. Is the agenda clear? What is the path variable and how it is linkage to the commands? Okay, let me close it. Now I am scrolling little bit here. So the first thing is everything is a file. Then UV and ls is also a file. And in Linux, almost everything is treated as a file. This ls is also a file, and where it is located, you can run this command, which I hope my screen is visible, and here it is showing me location.
Yeah.
I will open my, this is my file manager, and in the user bin, ls, it is there. So if I move to my Ubuntu folder, this is the main, and here inside the bin, there is ls, okay. So maybe I could search directly. So here it is ls, okay. I can open with a text manager. Yeah, text editor. And this is some binary file. It is not able to open. But this is a file, that is clear, right?
Mm-hmm.
Okay. So this is a file, and location I can think I can get from which ls command. So this is the next thing. Okay, let us move here. Okay. How is program get installed? You installed UV, how the program get installed? The first thing is, what is program? If I ask what is UV, what is ls, they are just a text file. Okay. It is just a text file. Just like a Python, they are text file. Then what is the meaning of install? We click in window, we double click. In Linux, we execute command and that get installed. What does the meaning of install? Installing a file means placing them in a standard folder like user bin or some other folder. Giving its permission, hey, you can be executed. And also notifying the operating system. Locating directly in path variable is the same way, notifying my operating system, hey, here is my program get installed. Okay. So for example, I have written a simple XYZ file. This is a single file. Okay. This is a single file. What is it doing? Just like the file is visible, the XYZ.
No, sir, your screen again, your screen is stuck now.
Oh, his screen is stuck again.
Again stuck.
What I can do?
Perhaps internet connection is.
Yeah. Well, after some time, it will not be issue. But now I hope XYZ is visible.
No, not
Yes,
still.
sir.
No.
Yes, sir.
Yeah, now it is visible.
Okay. So this is the XYZ file, what I have written. Can you see the line number 3 to 7? It is a if condition. If, then there is equi means equal. And this has means argument. If argument is equal to 0, it will echo. What does echo do? Can anybody remember what does echo do?
It will display.
Right.
It will print. Yes.
Yeah. So it is saying that if no argument, if the number of the dollar has tell how many arguments are there. Okay. Dollar has is how many arguments are there. So it is saying that if argument is 0, then print what I can do, and then exit the program. In all other cases, if -a option is given, print what all I can do. If say is there, then print what to say. If hi is there, then print I want to say hi. And if nothing is there, it is saying unknown option. Okay. Okay, so it is just like a if else and case. In Python, you have studied case. Are you able to map this thing?
Yeah, same time.
Same thing. Okay. So let me execute it. I will open terminal here, and I can locate that here is this file XYZ. Can you see the terminal and XYZ file in the ls command?
Yeah.
Yeah. So let us execute it. How to execute it? I will provide it location /. Means current folder. So this is the way to execute any script, and I will type XYZ. So the first issue is permission denied. My operating system say, hey, I cannot execute the file. So I need to give the permission. This is how executable permission. Chmod means we are giving a permission. Plus X means executable permission, and I will name the file this XYZ. And if I run the command again, it is printing because no argument I am giving, and it is printing. And if I type -a, it is say what all I can do. And if I type -a along with, if I type -say, it will say what to say. Okay. And if I type hi, it say I want to say hi. Okay. It is working fine. But what the issue? If I open a new terminal, can you see my new terminal open? Hello. Somebody audio is audible. Is my new terminal visible?
Sir. Yes, sir.
Yeah. So
Yes,
if
sir.
I type here XYZ, this is not available here. Okay. So I need to install this XYZ. Just it. That's it. So till now you have understood that if the file is there in this particular folder, that is this bin folder, if the file, the ls file is here in the bin folder, now my program is able to locate it. Okay, so I have to move the file here. So what I will do, I will copy this particular file and I will paste it here. But it is saying that, hey, this is a root permission. You required a root permission to move here. So it is not able to move. So I will provide a permission. I will move. Instead move, I will copy. I will copy this particular XYZ file to bin folder. Okay. In the bin folder, I will copy this particular file and with the same name XYZ. Okay. I will copy this particular file. Is the command is visible? I have written cp XYZ and
Yes.
you can see.
Yes, sir.
You can see that cannot create regular file, permission denied. So actually my operating system is saying that it is just like giving a run as administrator. So if I type sudo, it will run my command as administrator and move this file to XYZ. If here I search XYZ, so here there is no search result. I hope everyone can see that, right?
Yes.
Yeah, but I am now copying this XYZ file. I am giving the password. And now the file I was looking should be here. Can you see the file is now present here? Okay.
Yes.
If the file is now present here, I should able to run it from here. So it is now working. Even I can give option and even I can give other options like say. Okay. So I have installed a program. What is program? Program is a file and I have installed it. Okay. So this is how any program works. Even when you install UV, it download the text file and it plays at the correct place and give the permission. That's it.
Sir.
And the, just wait a minute. Also, this we call flag. If something is given minus, this we call flag, and this we call argument. But essentially, if you see that how internally it happened, internally everything, the first thing that you see, it is a command. All other thing that you pass is a argument. Okay, but there is a difference. If I here write ./xyz, it is saying there is no such files and directory. Okay, so there is one more thing to note down. Can you see the difference? If I just place / here and write XYZ, it is not executing. But if I write XYZ here, it is executing. Can you see this difference?
Yeah.
Yeah. Let me explain you what does difference means and what is its use. Okay. So if I type this dot, okay. So when I type anything, okay, I type anything. Okay. So or not anything. Let me type this XYZ -a I then say anything I have written. So how does it interpret it? First, the first step it took is to break down. So it break down into tokens. So it break down XYZ -a I and say. Okay. It break down into the tokens. Then then what it do, it take the first thing. This is the first thing. Okay, this is the first thing. Okay, so the first value, first value, if it contains dot slash, if it contains dot slash, it search to given path. Okay, in all other cases, I mean there might be some other condition. In all other cases, it see the path variable. Okay, so this is like that. Okay, this is the first thing, and all other value, all the other value means this minus a, high, and say. So like this minus a, high, and say, they are passed as argument. So this is how your
You meant to
command line
say
works.
dollar. Sorry, dollar path is the current directory. Whatever command you will put, dollar, it will go to the dollar path and search for that file, right?
I am saying that it looks, so what the first value, it execute the program. And what is program? File.
Command.
Okay, but
Yeah.
where is the file? Where is the file? The question is that if I write something, if I write this thing, okay, if I write this thing, let me annotate it so in the preview it will be visible well. I hope here it will be visible well. Yeah. No, not visible well. Why not visible well? Okay. Now it must be visible well. Yeah. I think this is enough. Okay. What I'm saying, if you write XYZ high, okay, it will break down into these 4 parts. The first part is a file that it will execute. The question is where to locate the file. So there are 2 conditions. Okay, if else. If this command, if this text has this value dot slash, it will search in the given path. In all other cases, it will search the path variable. Okay, what do I mean? Yeah, let me show you. This is XYZ, and here I will say that I am in live session. Okay, I have just modified it. Now, if I type XYZ, it is not saying I am in live session. It is saying what can I do. But if I type /XYZ, it is saying I am in live session. It means this .xyz is executing this file. But this .xyz is executing the file which is located in this particular folder or bin folder, /bin folder. Okay. And what I am saying that this is a path. Okay. This is the path. Even if I create a folder here like A, and if I move this particular file here, then this command will fail. But if I provide the path like this, A, so I am here saying the dot in the, okay, also there is one more thing. In Linux, dot means current folder. Okay. When you are referring path, it's current folder. So it is saying from current folder, go to folder A and then go to XYZ file. Okay.
Yeah.
Is this distinction clear that why this part and this part happen? Okay.
Yes,
so
sir.
this is how the commands are getting executed. Okay. And this is the role of path variable. Clear? Yeah. So let us move to the next part. How the program get installed. It is a text file, and installing means just providing the path so that it could locate. That is the program install. And this when you type how it works, I have already told you. The first part is identified as a program, and all other things are passed as the argument.
When we install the programs, any program, then it is placed in the particular folder, and the path variable is also modified accordingly.
Yeah, but if the path variable has already, the path variable is modified, but not always you need to modify it. Okay, because we didn't change the path variable for XYZ file. We have installed this XYZ file. Did we change the value of path?
Okay. All if you are putting in that folder particularly, then there is no need.
There is already, if the path variable has already some values.
Yeah. And if you are putting somewhere else, then we have to define the path variable.
Yes.
According to the good.
Yeah. Okay. And that is the next question. How you can define the path variable? Where to change the path variable? That is the question.
In the bashrc. In the bashrc.
In the bashrc we can change it. So what does echo path means? Echo path means and where it is set. That is the question. The echo path means it is just path is a environment variable, and it contains the column separated list of directories. So it has a long list and they are separated by column. Okay. So this is one directory. Okay. This is second directory and this is third directory. So there are 3 folders here listed in this current part. Everyone is able to see the 3 folders.
User local bin, user bin, and bin.
Yes. Now the value, the question is, where does the $path come from? Because normally to set the variable, we type like hello a is equal to hi. Okay. Then we do echo a. Echo $a. It is coming as hi. So my question is exactly like that. Where does the path variable is set? The answer is path variable is set by the operating system itself. Okay, so you cannot change that. That is the first part. Second part is we can change the path variable in the cell here. Temporary change we can do, right? You can change the temporary here. Am I correct? I have changed the temporarily for the path variable. Okay, so there is temporary change we can do, and that temporary change we do generally in the bashrc. And the flow of bashrc, what happens? Okay, so when you start the cell, okay, whenever you start the cell, okay, the cell will be started. Okay, after cell the bashrc files runs. Okay, and then your terminal open. Okay, this is the flow. This is how it happens. First, when I open terminal, first bashrc file run, and then the terminal got open. So anything written in bashrc, that will run first, and that will be available to the other cells. Okay, so let us move to the bashrc part. So here I will type something like a file. Okay, just let me type the file a. Why I'm not okay? There is folder named a. So let me type a file b. Okay, here I will echo $a. Okay, and I will run this from terminal. I need to give its permission, and I will run it from this terminal. So this is how I can I have to give permission to B, and I need to run B. Okay, so can you see if I run B, no output I am getting. Can you see this?
B contains echo $.
No output, no.
Okay. Yeah, B contains echo $. I can show you that echo is working, like echo where value. Okay, I can show like this. This var value is executing, but this var is not getting the value because it is just printing empty line. So what I will do, I will move to home folder, okay, this home folder, and there is this bashrc file. Okay. Oh, I have opened the Gemini API key anyway. Okay. So I will, here what I will do, I will define the variable name. Okay, let me define var1 and its value as 1, 2, 3. And let's define var2, its value as 0, 0. Let me define just 0. Okay. And I will say some, okay, let me say 4, 5, 6. And here I will write export. Okay. There are two things. Both are different. Okay. Defining the variable there are two ways to define variable. This is the, okay, so this is variable part, variable, and this is cell variable, and this is environment variable. Okay, this is cell variable and this is environment variable. If you just add export thing. Anyway, we have run it and we have saved it. But the question is, does bashrc run? Bashrc run, what I have written here, when bashrc run? Yeah, I will take more, only 5 minutes more. Yeah, my question is, what I said, when bashrc file run? When bashrc file run? Just before start of terminal. And to be frank, it is interactive terminal. There are different type of terminal. We are talking about currently interactive terminal. We can click on cursor, we can interact with. So if I start a terminal, before that bashrc run. This terminal is not started, so bashrc won't run. Here I will print var1 and var2. Okay. Here I will run the B. The var value doesn't change. Not printed, var1, var2 not printed. But this new terminal, just I have created a new terminal, and here if I run, it should be okay, I have not saved it. Okay, let me save it. Now it got saved. And if I again try to print, nothing is printed. But if I reopen a terminal, now bashrc has run and it has set the environment variables. And now 4, 5, 6 I am getting. So here, am I audible?
Audible, sir, audible.
Yes.
Yeah, so here I am able to see 4, 5, 6. Note this, nothing printed here. And also note thing, the bash cell that were already running, here still I am not able to get this var2 value. That's clear? And why I am not able to get that var2 value? Hello?
Yes, sir.
Why I am not able to get var2 value if I am running B here?
bashrc is not it is just create before the bashrc, na?
Yeah, bashrc run
Yeah.
before start of a terminal. So if I start a new terminal, a bashrc will run and it will be applicable for this terminal only. Okay. And this and also bashrc run for interactive terminal. Okay. There are different
Interactive terminal as in?
Yeah, where you can interact. Here you can interact. You can type anything. You can go back space. You can see output and you can again interact. This is interactive terminal. There are other type of terminal we will talk about later. So bashrc run just before start of interactive terminals. Okay. Now the second part is I was talking about.
And bashrc runs only for that particular terminal.
Yes. Okay. Yes. Now the second part is this is cell variable and environment variable. What are the difference? Okay, cell variable, it is available for current cell only. Okay, and there is environment variable. it is for current plus child process. Okay, it is for current and child process. So what happened? You click on terminal. Okay, it runs bashrc first. So bashrc run is a process. Okay, so that is available for that current cell only. But then there is a child process start. That is your GUI terminal. Okay, you can think like that.
Subshell.
Yeah, you can think like that. The terminology can be different, but for now, let us say that it is bash. Okay. Then a subshell of bash work, and it is you can treat like it is a child process. Okay, and that variable to access here, you need to add export. That is environment variable. Okay. Okay.
Environment variable is required for the child processes, right?
Yeah, so you never use this. Okay, cell variable are useless. Okay, why you will write something here? Okay, they are useless. You will always write export and then variable, then its value.
So when we export it, it will go to the bashrc or not?
Yeah, you are writing in bashrc.
Okay, export means you are writing in bashrc.
Yeah, you have to write in bashrc. Export means if anything is start in subshell, this variable will be available to that. So here in the terminal, that variable is available. Okay.
But that export RC is in the bashrc variable 2.
Yes.
V2 is there.
Yes, the text editor is opening this bashrc file. You can see that.
Okay, fine. Okay, fine. Okay.
Where does this bashrc terminal appear?
No, bashrc. This is not a terminal. This is a file. Okay, it is in your home folder.
Okay. Where do we have to go?
You are in WSL, right?
Yes.
Yeah. So in WSL, go to Linux, then home, and then let me write it. Open your file explorer. Then below this PC, there it will write Linux. Go there. Click on Ubuntu.
Okay.
Then click on home folder. Then there will be your username. Okay. Click on that, and make sure to enable showing hidden files. Okay.
In my Ubuntu, I can't see the home folder as such.
Hidden files, and if you show the hidden file, the .bashrc file will be visible. Okay.
Okay, bashrc. It's like a text file or what?
Yeah, it is just a text file.
It's a shell script.
It is a text file. There are many things written. Don't edit that. Okay, just append something. Never modify. So these are the things that are written in bashrc. Okay, these are the different things written. It runs before the terminal starts. Okay, so that much is
add, right? Basically.
Sorry.
We can add things to it. Append.
Yeah, you have to append it. Okay, and make sure you save it. If you don't save, that part will be lost. Okay.
So is it like control S?
Yeah. So, yeah, so that's it. I think everything covered in the bashrc. That's part cover. If you want a notes, here notes is there. In Linux understanding, here it is there. And if you want a detail, like what are the different types of cell, for TDS course, the interactive cell is more than enough. But if you want to understand more detailed cell configuration, here I have written there are login cells, interactive cells, and non-interactive cells. And there are 3 types of file. One is bash profile, one is bashrc, and there is one more variable, that is bashenv. I have not talked about all this because these are not much important for TDS course. This file is important and we will edit, and it is for interactive cells. Okay.
How to find bashrc file?
Yeah, that I have just showed you know.
I was unable to.
Yeah, here.
Good.
Yeah, can you read these instructions? What I have shown written.
Yeah, but
Would you mind to paste this in the somewhere in
Home
the
directory. Home
notes?
directory.
Maybe I will do something like
So when
that.
will get this on YouTube? Today or tomorrow?
Okay, so one more thing. So if you can see this calendar, okay, this session has ended at 12 p.m., right? This session one, right?
Right.
Yes, sir. Yes, sir.
So what happened when we start recording? No, this recording is happening by Google Meet, and Google saved this recording to Google Drive, and that recording takes some time, so 2-3 hours. Definitely after 12, it is 4 p.m. So time are up. If I click here, and if I scroll down here, you can see that drive link is also now present. Can you see? Every time for all the sessions, if the session is recording, that will be saved in G drive, and here you can find that link. Okay.
So sometime it becomes inaccessible or ask.
If it is inaccessible, it means we have manually done that. So there might be some issue with that video. That's why we have done that. Otherwise, you will always able to see here the recording. This is the first thing. Second thing, whether recording is happening or not, you can see here. Can you see here? And here it is also written. This call is being recorded in the top left corner. Can you see that?
Yes.
Yeah. So it means recording, and this recording feature is for Google only. It means the recording will be saved in Google Drive, and all the invited hosts can see the recording here. Okay.
Yeah.
Sir, in case some class we didn't join, how we can access, sir?
Sorry?
In case some class we didn't join and but we wanted to view the video, if only attendees only can check.
No, I'm not saying attendee. I am saying whoever have been invited.
Okay, sir.
All the invited person can see this. Okay. Fine.
Thank you, sir.
This session recording has okay. This session, I think the first recording. This is recording 2. It is happening, and the first recording was, I think, was closed with some issue. That is why there are 2 recordings there. Okay.
Thanks, Ritik. Am I audible?
Yeah.
Okay. Sorry that this session ran a little bit long, but I just wanted to cover couple more things before we finish. So, because we were talking about networking, and I wanted to illustrate something very important about how to think about your systems communicating with the outside world. Any questions so far? I mean, or shall I continue? Okay. I'll assume I can continue. So I fixed the problem earlier we were having, which was the VS Code was not working correctly. So the way I fixed it is I uninstalled VS Code completely, and there are 2 directories called app data and I think user profiles. Both of them had some residual files in there that were causing a corruption. So I had to delete all those things. And then once that was deleted, then I installed VS Code and it's working fine now. In one of the sessions, not today, but probably tomorrow, we will show you how to set up your VS Code also, like with the what extensions are good to have and things like that. So I won't show it now. Yeah, I won't show it now. But I'll finish the networking bit, and then it'll take only about 15 minutes more. So I hope that's okay with you guys if I just finish.
Yes.
So we can watch it later.
Sir, can you, sir, for the tomorrow session, can you start with the networking, sir? I think.
So you don't want me to do it today? Is that what you're saying?
Okay, today it will fine. If you discuss today, that will be fine.
Okay, yeah. Okay, is my screen visible?
Yes, sir, visible, sir.
Okay, right. So if you remember earlier, right? So we were talking about we have a service running, and if I run it on, do this again. So I hope you can see this clearly. So this is running on 127.0.0.1 and port 8000. And if you remember, we were able to access it even from Windows because Windows decided to break the rules of how this should really work. And therefore, it was still kind of working through Windows. Okay. Ideally, that should not happen. Okay, there should be perfect isolation. The rule about 127.0.1, the specification that has been given by the network engineers is this is only should be visible within that specific computer. Even if it's a virtual computer, it should only be visible within that virtual computer. But for some reason, Windows decided to do their own thing. Okay, so that's why we were still able to access this from the Windows machine. Okay, but now what I'll do is I'll stick with this. Okay, for a minute, I'll go back to running this on 127.0.0.1. Okay, and then the next thing I want to show you. So this was the WSL. Okay, now this is the PowerShell. Okay, in other words, this is now our Windows machine. Okay, it's external to our Linux machine. Okay, so if I do a curl command here, okay, http, and I do okay. Before I do that, something else I need to do. So if you remember, this was the address of our internal Linux machine. So it was in other words, it was the network card address. Right? So if I make a note of it here, so that we don't forget what it was. Text. I'm going to, sorry. Okay. So this is our VM. Okay. I'll, maybe
VM starts with 172, and the hardware machine, our PC starts with 192. Is it?
It's how Windows assigned the IP address.
Yeah, normally.
Yeah. We didn't assign them. Windows itself assigned it. Okay.
Okay.
So I'll also put on here and say VM. Or yeah, actually that's more accurate. So anyway, so this is the address that is given to the card that's sitting inside WSL, and then if I do this in green, I say this is the Windows machine. Okay. And this also will have an IP address. So if we go here, I think it's IP config. Yeah. And you can see there are multiple network devices on here as well. Okay. There is a wireless LAN card which has this address, which will be useful in just a minute. So I'll copy this, put it in our little diagram here. Okay, so this is the Wi-Fi adapter.
Hello, sir. Can you show the where you copy this 192.160?
Yeah, sure. I'll just put this on here. Oops. And then this a bit bigger. This to the front. Okay. So these two are now what's on your system. And if I go back to this over here, so I use this command called IP config.
IP config.
Yeah, I do IP config, and it shows you all the network devices that are there on the system. Right, so there's some Ethernet 2 is there, which has some IP address. Then there are some other wireless LAN cards, and various things are there. But we are interested in what the Wi-Fi address, what the Wi-Fi address gives us, and that was
192.168.
Yeah, just trying to find where.
Here it is. Yeah, LAN Wi-Fi.
Here, yeah. So wireless LAN adapter Wi-Fi.
Yeah.
This number has been assigned by the router. Okay, you know you have a router in your house, right? So when my
Yeah.
Windows computer connected to it, it was given this address by the router. Okay, so we noted that. So it's assigned to our Wi-Fi card. And then inside, you will notice also there are some virtual adapters, right? So here is a virtual adapter, and it's notice it says WSL, and it says this address. So what Windows does internally when you're creating a virtual machine is it creates its own little network, and then on that network also the Windows will have its own virtual card as well. If I go back to our little diagram here, if I put a little thing here, and if I say put this, if I go here, so this, so you can think of this as a separate card, okay? That is, so you have a Wi-Fi adapter, you have an Ethernet card which will get an address, and this is also a kind of Ethernet card, but it is invisible to you. It is virtual, okay? And what that does is it connects. Fill to make this line sort of red in color. Yeah. You can imagine this 192.19.32.1, which is on your Windows machine. It's connected to your WSL 172.19.4580. Okay, so these are sitting on its own internal network, so they can speak to each other. Okay, so have this visual picture in mind. And now what we'll do is we'll start this server, the Uvicorn, on 127. Okay, so it's starting on 127. So remember, the idea is it is broadcasting within itself. Okay, so if I do this little purple thing here, okay, imagine this is the 127.0.0.1. Okay, this little square. Okay, and when your application is running, it's saying any applications inside the WSL can listen to this. Okay, and so that's what the server is doing now. Now what we'll do is we will try to run the curl command and see what happens. HTTP, and we want to connect to 172.19.45.80, and we said port 8000, right? So let's do that. Okay, not working, right? But if I do this, sorry, what's the number? 45. Oh wait, that also is not working. 172, 19, 40. Oops. Hang on. Yeah, it will not work because it can't, it's not listening on from the external port. Okay, 72, yeah, that's correct. So if I do this, it will work, but if I do 172 HTTP, yeah. Copy this. Yeah, so if I do this, it is not going to work. Okay, because it cannot listen to the machine that is, or the service that is running inside the virtual machine. Okay. But it's able to do this because Windows cheats. Okay. So that's why it's able to do this. But in reality, it should not be able to connect directly. Okay. So then the question is, how do we fix this problem? So we use a command called netsh.
So the command curl HTTP for what, sir? Curl is for what?
So curl is a command to fetch, what you call for it, a HTTP page. So the internet pages that you serve up, right? Usually it communicates using a protocol called HTTP. That we will do in tomorrow's session. But today you just have to remember that it's to fetch any internet addresses.
Okay, for the particular IP address, curl is to fetch this particular IP address.
Correct.
Is the curl IP address correct? 1945.
I think it is 1945-80. Yeah.
Where did we get that from?
So we got that from inside the WSL machine. I did IP address show, and it shows me that this is the address of the card.
/20 is also there.
Yeah, don't worry about the /20. That's a subnet.
Okay.
But if we connect to this, it should, in theory, be able to respond, but it's not responding.
Okay.
So what we can do, actually, before I even do that, let's try this. Instead of broadcasting on 127, now I'll do it on 000. Let's see if our curl command is now able to work on it. 45.80. Notice the big difference now?
It is able to.
Yeah. That same card, which earlier it could not listen inside, now it's able to. So the reason being, I decided to host it on this address, 0000. What 000 does, and this is very important to understand this, 127 means only broadcast within this machine. Nobody else from outside should be able to connect or listen to what's happening inside. Okay. The broadcast is only for inside this WSL machine. Of course, Windows cheats and listens in as well, but in reality, that should not happen. Okay. But now when I say 0000, what it's saying is, hey, there are many network devices inside my WSL machine. Okay. And one of those network devices is 172.19.45.80. Okay. I want you to broadcast not only on 127.0.0.1, I want you to broadcast on 172.19.45.80. If there are any other IP addresses that are assigned to this local machine, that WSL machine, I want you to broadcast on all of them. All networks that I am a member of, I want you to broadcast on all of them. So that's what the 0000 does. So that's why if I go back here, when I decided to run this web server on this host, all the network addresses, that is the 127.01, the 172.19.45.80, all of them are able to hear what's being broadcast. And now, because the Windows machine also is sitting on this same network, 172.19 network, now when I run the curl command, it is also able to listen on the same network. So that's why you get this, right? So now if I say yes, look at the content that comes out. It's the same thing from our server. So now our Windows machine is able to communicate with the Linux machine sitting inside the Windows machine. This is the normal workflow of what's happening as far as a network is concerned. I know this might take a little time for you to appreciate it, but many TDS failures happen because they fail to understand this distinction. Okay. Now, the next step up from this, right, is to also understand now your computer. is sitting on in a router, right? And in your house, there'll be 3-4 computers. In a corporation, there will be hundreds or thousands of computers. How do they connect to your WSL machine, right? You have created a project, TDS project. You're running it in WSL because all the tooling is there. Great. It's also visible now in your Windows machine, but it's not visible to other machines, say, okay, on your network. So how do you make that available? So one way to make it available on the network you're currently sitting is to use something called netsh. Okay, it's a command that is now this is only for Windows. Okay, this is not an issue for Mac or any of or Linux machines. So what I'm showing you is mainly because of this problem of WSL sitting inside Windows. So to get access to this server, there's a command called netsh in Windows, and what you do is you tell netsh to create a tunnel to listen to any requests that are coming on your network and send it to the WSL machine sitting inside it. Did you understand what I said? I'll repeat it again. I'll do it with the diagram. netsh, if I take this pipe here, give it a different color. So what netsh does is it says, I want you to listen for any traffic on the main network. Okay, and this main network will have other computers on it. Okay. So there maybe somebody's got a phone, someone else has got a television, and someone's got a MacBook. Okay, so they're all sitting on this network, which will make a copy of this. Okay, so they're all sitting on this network. Okay, and netsh allows you to create a rule that says, hey, I want you to listen to anything incoming on this network. But not only that, I want to also if something comes. So if anything comes on the network and it's coming on, this is where the concept of port becomes very important. Okay. Listen on the network, and if anything comes on port 18,000, say, okay. So I have a MacBook here, and I'm going to send. Now remember, we sent a curl request from here, and WSL showed up the content, right? Now I'm going to say from my Mac machine, right? I'm going to say I want to send a curl request, but send it to this computer, which is with this address, on port 18,000. Okay. If it comes in on port 18,000, so I've set up a rule. Hey, listen for port 18,000. If someone is sending something on port 18,000, what I actually want you to do is send that information to WSL on port 8000. So that's what this netsh will help us do. Right? This is a concept called port forwarding. So if you want to look up that information, you can look it up. Port forward to 8000. Okay. And not only port 8000, but you want to forward it to that particular IP address, 172.19.45.18. Okay. So this is what netsh will help us do. So now that we got this concept in mind, so any questions at this point before we actually build this? Okay, everybody's fine.
Once we broadcast with 0000,
yeah,
then it will be accessible with all these machines, is it?
No, it will be accessible to all the machines that the WSL is part of the network that the WSL is part of.
Okay, WSL. If it is,
So if you look here, there are two devices, right, on the WSL. There is 127.0.1, which every machine will have that.
Yeah.
But there is also, can you see 172.19.45?
Yeah, this is virtual machine.
Yeah. So any device that is sitting on this network also will be able to hear the broadcast done by the application.
Okay, then how we will check how many which machine is sitting on this virtual machine?
So the way to find that out is, okay, so when we look back at our Windows machine, so you remember up here, you can see, so this network, so this network was created by Windows, okay?
Yeah.
We didn't create this network. So, so part of this network, there are all these devices on there. And one of those networks are the 172.19. And notice this also is sitting on the same network, 172.19. Now, there is a little more advanced topic called subnetting. I don't want to take you into that right now.
Okay.
But that will help you understand it even more deeper. But like I said, networking itself is a major concept. But I want to at least give you the basics of what's happening. So if you think of this as Chennai and this as Madipakam, so this 172 is Chennai and 19 is Madipakam. The rest are like street addresses. Right? So this is what's called the network part, and the rest of it is called the host part. Okay? So
Carlton, if a little bit of, maybe some small notes can be made on this, might.
Yeah, we have a very good resource actually that we will share.
That would be.
But I just wanted to at least get you an understanding of what's happening, right?
Yeah, then we will make practice on that by bit and trial.
Yes. So, going back to our original diagram here. So remember, WSL is sitting on a 172.19 network. So that's why these are both in quote unquote Chennai. Okay? 172.19, 172. And then these are the individual address. WSL has 4580 and Windows has 32.1.
The second one after the dot is the subnet, right?
No. That is not exactly right. But that's why I didn't want to get into it. That's a whole. That is a whole nother discussion.
Okay.
So don't worry about subnetting just yet.
Yeah, okay.
It'll make
sir,
it
actually sir, actually what the pipeline is doing, the system which gets some data on port 18,000, it will forward to the WSL.
Yeah, we want to achieve this, right? Anything that is being broadcast on this network on 18,000, what I'm saying is listen for it, okay, on our Windows machine. So Windows is listening now, okay? And if it hears anything on 18,000, I'm saying, okay, what I want you to do now is, since your Windows machine is a member of this network, send anything on 18,000 to this IP address and this port number. Okay? Now we are going to do exactly that. Okay? So if you look at this command, okay, it says, so it's not that difficult, but it's netsh. There is, you have to use this keyword called interface and port proxy. Okay? So these three things are part of the command. And I'm saying I'm adding a new rule to it. Okay. And the rule is, so this V4 means, so these IP addresses that you're looking, you see there are 4 components to it, right? Something dot, something dot, something, right? 4 components. So this is a V4 to V4 rule. So that's what this means. And I'm telling, hey, remember what I told you? We want to listen on 18,000, right? And the other thing we wanted to listen on is 000. So listen to the broadcast. Anything that's coming on any network interface at port 18,000, I want you to listen to it. So this is inside the Windows machine now. And then send it where? Connect to 8,000, but which address? To the address inside this WSL. Okay. I'll create this rule. So now this rule is created. Now you may say, okay, how do I know the rule is created? So there is a command called net.
Sir, why we give listen address at 000?
Okay, so the reason we did listen address 000 is because inside, so remember, this is the Windows machine. I know this doesn't help because the colors are not the same. So next time I'll give the Windows shell a different color.
We have to remember this command of netsh, or somewhere it is given.
You can look this up. It is not difficult, but I'm just telling you the components of this command, right? So we created a rule that says listen on 18,000, and the reason we give 000 is because on the Windows machine there are several network devices, right? So I'm saying on those, listen on any of those network devices. If something is coming in on 18,000, I want you to send it to 8,000, but on this machine, which is your WSL machine. This 172 is your WSL machine. Okay? So all this line is doing is exactly what this diagram wants. Listen on 18,000, send it to port 8,000 for this machine. Okay. And the way to find out if that rule has been done is you use this next command called netsh interface. Again, same thing, netsh interface proxy, but instead of add, you say show all v4 to v4 tunnels. Okay? And so this is what it is. It's a tunnel that's been created, and it's listening on all the interfaces of the Windows.
This is a keyword. V4 to V4 is a keyword.
It's how netsh is constructed as an application.
Okay.
It's one of their rules. Okay. So you can look up the netsh documentation and you will get a whole bunch.
Okay, fine.
But you can see the rule is here, right? Okay. So now that rule is constructed, what we can next do is I'll start sharing from my Mac OS. So this is now sitting completely outside the Windows system. Is my screen visible?
Yes, sir.
Right. So now if I do the same curl command, which we did initially inside Windows, right? So you'll notice something now. Remember, the Windows machine is 59, right? So the long story of it is it's not working. So the question is why? Okay, we created a tunnel, but it's not working. So what I'll do is I'll go back to our Windows machine and tell you what the problem is. Oh, maybe I have to stop presenting. Okay, you're able to see the screen now, right?
Yes, sir.
Now, what the problem is Windows has a firewall. Okay? Firewall is a piece of software that protects your computer from external attacks. Okay? But the problem is we want to communicate via port 18,000. But Windows doesn't know that port is safe or not. So we have to tell, hey, look, make an exception. So the firewall is like your, the guard who sits outside your
entry gate.
Yeah, your entry gate or your your apartment complex. There will be a guard there, right? So your firewall is like that. So when a friend is coming to visit you, right? If you don't tell the guard, then what will happen is he won't let him in, right? So you have to tell the guard, hey, my friend is coming in. This is his identification number, 18,000. You can let him in, no problem. So that's what we got to do. If I go Windows, so this is inside your settings. So this thing comes up. Then go to advanced settings. You see advanced settings here? Over here? Hello?
Yes, we can hear you.
Yeah, okay. We can see.
Okay. So then once you go into advanced setting, there is this inbound rules. Okay. So what this inbound rules is telling, hey, anybody coming in, this is the rule I want to set up for it. Okay? So you go and create a new rule. So what are we doing? We are opening a port. So I clicked on port, said next, and then we can say which port? 18,000. We want to come on 18,000. And TCP is fine. So remember earlier I talked about TCP and UDP. You can even specify that.
Yeah.
This is a normal TCP connection. It's a normal HTTP TCP connection. So just leave it at TCP and 18,000. Okay. What do we want to do? Allow the connection. Where does this rule apply? Now, typically, these bits will be useful. So say, for example, if you set up your internal home network with a domain name, that's possible. Okay, you can say, if I put Shrikant as Shrikant.com, whenever I type Shrikant.com, that means I'm referring to my internal home network. So that's what this domain thing means. Okay, anything within the domain where your computer is operating. And if you remember, when you're connecting to a Wi-Fi, usually your Windows machine will ask, is it a private network? Is it a public network? It will ask you that question, right? So this tells, shall I allow listening to 18,000 when it's on a private network or a public network? So this is what this means. Okay. If you remove public, then what will happen is anytime you say, for example, you take your computer and you go some other place and it's a public network and you tell Windows this is a public network, then it will no longer listen to port 18,000. Okay. But if you're in your home network and you tell, hey, this is a private network, so then what will happen is it will listen to all connections on that. For now, I'll just leave it all as ticked. You can adjust this according to your situation. And I don't want to get into too much detail because, like I said, networking itself is like a whole semester subject. But I'll leave this here for now. We'll just give it a name. So we'll call this. So it will be at the top of the list. So AAA TDS hello. Okay. So say finish, and you can see the rule is up here. Okay. It's you can double click and see what it looks like. So it's enabled, allow the connection. The protocols are all fine. Then if you look at the advanced, okay, all that is fine. Here are some.
External firewall. What if there is an external antivirus or a firewall, AVG or something like that?
Then you would have to configure it in there. Yeah, you'd have to open up a port in your firewall. And that's beyond the scope of what we are teaching. But I want you to be aware why things fail, right? So this is a very good reason why things fail. We saw failure, right? So I'm showing you that you have to open up a port. You have to tell the firewall, hey, let this guy in. Some other things are there as well, block edge, traversal, etc. These are all various security features. And it's beyond the scope of our discussion today. But okay, let's try this. Okay, we created this firewall hole, and now hopefully when we say do the curl command, it should work without any issues. So let me go to the Mac machine.
So in this one, basically you are trying to connect your Mac to the Windows one, right?
Yeah, it's more than that. I'm actually trying to connect to the WSL that is sitting inside Windows.
Okay, from your Mac.
Correct. Okay. So earlier it failed, right?
Yeah.
So let's run the command again. And it worked. See?
Yeah,
now the application is visible on my internal network. So this is what I wanted to show you. This complication arises primarily because we are working with a VM sitting inside Windows, which is then sitting on it. And this is the vast use case situation for most of you. That's why we felt it necessary to at least make you aware of the networking problems you may encounter when trying to make your applications visible. But this by no means is the complete thing on networking. least we have made you aware of how networks work, how they communicate with each other, and what are
in the later sessions we will do some example to upload application and just check whether it is visible or not visible. Then it will be better.
So there are some workarounds to this. Okay. So
Okay, we will do it.
So the workarounds, instead of setting these complicated communication networks.
Yeah, it is complicated. It is complicated. Not lot of hardware and software is integrated in that.
Yes. So there are some workarounds where you are able to expose an application to the internet, and that is using some tools. Okay? So there are some tools like NGRock, for example, okay? Or there are Cloudflare tunnels. So there are various tools that are available that allow your application to be exposed to the internet. But the reason I didn't want to directly give you the easy tool is because I want you to understand the complications of what goes wrong when you're trying to make an application that is sitting inside WSL visible to the world.
Carlton,
yeah.
From data science point of view, like I'm just asking. So how is, because these things look a lot more like the networking part, right?
Yes.
Somehow.
Yes.
So how like exactly data science, we are being, since it's a part of tools in data science. So how like, we are relating this to data science? Just wanted to understand.
Yes, that's a very good question. So the problem with the jobs in the real world nowadays is people are expecting you to build an entire MLOps pipeline. Okay? So it's no good that you can build a model and you can create predictions. From a job perspective, what Professor Anand has told us from his exposure to industry, nobody is interested in that nowadays. They want something more than that, because with the power of GPT, you can easily create models and predictions and all these sort of things. What is lacking is the skill to build a pipeline. Right?
So end to end, basically.
Correct. So from that perspective, this becomes very important to understand how networks and how computers communicate with each other. And I hope I've exposed you to that, at least in some simple way, so that you can appreciate, what these cards are doing, where they are sitting, how it's communicating with these networks, why ports are important. I hope I've conveyed that information to you so that when you use things like Docker, for example, Docker will create its own little virtual network. And the containers inside Docker are all like little VMs. And if you want them to communicate with each other, you will have to understand how these work. Right? So this is where a lot of the failure points come. Not understanding how a VM communicates with its host and how a host exposes itself to the outside world.
Actually, I have a small suggestion. Thing is that like I am from the diploma in data science.
Yes.
Batch.
You're exactly the kind of people we are targeting, so that you understand the complexities.
I understand. Yeah. So the thing is that maybe in future if you can develop some kind of a bridging course, right? Yeah. Because a lot of things people from various backgrounds, they will not be knowing this. I am from a completely power sector background, so this thing is very much different. Yes. Though I have some understanding, but my forte is in some different angle. Sure. So probably if you can do something with this, it's good.
So this is all part of what we will eventually put in a bridging course. So we are doing these sessions, which we never did in previous terms. In the past years, TDS never had this pre-term sessions. And the idea was basically to target people like you who are not from this background, so that at least you have an appreciation for what the challenges are and how you can go about solving them. Because remember, these are like logical layer problems that a GPT will not be able to one-shot fix you.
Because I think in diploma in programming, I think people cover a lot of aspects in like system commands and all, right? I think so.
But even they will struggle with this concept, okay? But they will find it a bit easier because they have a little more exposure. But conceptually, this is important to understand what's happening. My main hope is that you have taken away the concept. I know you might have to watch this video again, but at least I hope you have understood what's happening. I know these graphics were not very good. But,
No, it's okay. It's okay. I'll have to watch it again once. Yeah.
Right. So that's all. I'm really sorry that the session went an hour longer. We had some little bit of trouble earlier. Just to prove that it's all working, I'm connected inside WSL now. And you can see this is the folder we had looked at earlier. And I'd created this FastAPI application. And you can see it's connected to WSL.
Also, like, you would be teaching these API things and all because...
Yes, yeah, it's part of the course. So we will be teaching you those things. So tomorrow's session will cover more along the lines of what HTTP protocol does, what HTML and CSS does, how you can scrape that using JavaScript and things like that, and how communications generally happen in a more detailed way, but not at this low level. We'll talk about more on the application level next session. Yes, Bhaskar.
Will there be a session to help overcome some of the problems in this entrance evaluation? There are a couple of which is nothing to do with this problem discussions, but it's more to do with WSL being hosted in GitHub.
Yeah. Okay. So there is a discuss button.
I did, and there are a couple of comments, and then there was no response. That's why I thought I would ask you.
We are piloting that idea of discussing directly on the questions. We only made it available today.
I did see that.
So it will take like a couple of days for people to get used to the idea. We are piloting it to see if people find it useful or not, or if there are improvements we can do.
Good. Thank you.
And this entrance criteria is not there anymore, right?
Yeah, it's not a strict criteria anymore because there was some pushback on it being too sudden. But probably for next term onwards, they will stricten or tighten it.
No, we'd like to know where it doesn't work, irrespective of whether you admit us in there or not.
I mean, those are largely decisions done by the prof and the operations team.
Not from the point of admitting into the course or not. We want to know why it doesn't work.
Sorry, why it doesn't work?
Yeah.
The question you're talking about.
Yeah, the question was.
Yeah. That you'll get some support through the discuss, and the TAs will also be looking at it.
Okay.
And they will provide feedback. If where necessary, then I may also comment on it. But these problems that they have shared with you are mostly problems that have already been solved. So there is just some learning curve involved with it, and others can get together. And the idea is to build bridges with your peers so that people who have solved it can then.
Actually, Carlton, one more thing.
Sure.
So basically, like people, who are solely doing deployment data science or deployment programming. So these deployment data science people, they can opt for deployment programming subjects.